Welcome to part 2 of my tutorial on OpenOffice Base, a free database product available for you to download in the OpenOffice suite. OpenOffice is made available by Apache and Oracle for you to download without registration. They do not require internet connectivity to work. They are free, and OpenOffice Base is the database function. Very useful, especially for learning, not as high featured as Microsoft Office or other database tools, but a very excellent source for learning. And from our first lesson, we downloaded and installed OpenOffice Base, and we learned what databases are. Databases are groups of tables, not unlike spreadsheets. But unlike spreadsheets, they are knit together by a logic which allows you to query more than one table at once, allows you to sort the tables through their common attributes, shared columns in tables. Having information organized into a whole different set of tables makes things more efficient. If you have everything in one big table, you have to rewrite everything every time you save. You have to hunt around for the information you want. It's quite ponderous. It's not plausible at all for an enterprise of any size. A relational database allows you to keep information discretely in separate tables where it is easiest to organize and prioritize your access. Because opening and closing tables always runs the risk of transcription error. And having information stored in more than one place on a table creates the issue of items not being properly saved. Relational database solves these problems, and we'll learn how this works. Gave you a quick demo last time. We're just going to do some simple functions, not even database functions, on a table. These are functions you see in a spreadsheet. But I'm going to start right now by just showing you how sorting and filtering work. You do this in spreadsheets all the time, but they're very helpful for databases as well. This is the landing page for OpenOffice Base. Along the left are the four options you have to look at tables, queries, forms for input, and reports, which output data is very presentably. Up top you have the task panel, and below you have the tables available for you to consult. And we are going to select a table from the bottom panel to view. We're going to look at the farm products table. This was the table that had the particular crops that are growing in our farm. Here's the farm products table. We selected it in view mode or update mode as opposed to design mode. In design mode, you might remember, you create a table, and in view mode or edit mode, you you add information to the table, add specific items for the table to hold. It's the difference between building a house and occupying the house with people. And you see a very simple table here. It has crop numbers along the left, a serial number for each crop, the name of the crop, growing season it's in, what soil it requires, whether it's drought tolerant, and some information on costs and profit per acre, just like a regular spreadsheet. And like in a regular spreadsheet, you can filter and sort the data, rearrange it rearranging it in by column row, by the order within each column. So let's look at the sorting query inside OpenOffice. We go to the tables feature and click on farm product. Now we could, if we wanted to edit how the table is structured, we go to edit. but we're not doing that. We just click on it to view the data. And then, of course, in this function, in this mode, we can also update and add further grains if we wanted to. But let's look at the sorters. It's very simple. Let's sort by farm product alphabetically. And just like with a spreadsheet, you can sort ascending or descending. And you can also filter. So let's select. We only want to look at soil types, and there are all the different conditions you can search for. Since we're looking at a soil type, which is a word value, we're going to look for soil type dry, and this will eliminate all the fields, all the rows that don't have dry soil required. And now let's undo the filter, bring back everything. And of course we can sort by a number value. Let's choose cost per acre. Cost per acre, of course, we can go greater than or less than. Let's go cost per acre less than 100. And we've eliminated everything where the cost per acre is in excess of 100, which I think was only one. But with these standard filter features, we cannot move the columns around. We cannot remove columns that we don't want. That requires us to use a query. Now, what's a query? We did them before. Query allows us to arrange the table by different columns. And if we wanted to, for example, drag the soil type column over to the left and then order the soil column alphabetically descending or ascending, we would then have the entire table arranged by soil type. It would be a very useful way to look at how soil type determines what crops are available, what soil, what costs and profits we might see, what plants are grown when. Okay, so going into depth now on a single table query. A query engine, this is completely different from how a spreadsheet works. Query engine allows us to arrange a table by any number of different columns. There's a chooser, which will allow us to select the columns in the table we want, and we can move the order around as well. This will allow us to present the data in a manner useful to the person who needs the information. So query returns a table, but a query does not save a table. Query only saves the specifications of the query. And if between times calling the query, the underlying data and database changes, the table that's returned at the end will be different. The query will change as the underlying data changes, or at least the information returned by the query will change. And all the information comes back meshed into a single table. So we'll create a query using design mode. We're not using the wizard here. Query is chosen from the tasks on the left, and in the top panel of options, you select Create Query in Design View. And this is what the chooser looks like. You choose the table or tables you want to query from this chooser, and then you will choose the columns that you want displayed in your query when you make the query. This chooser has 3 stages. 1, look at the columns available. 2, select the table you want. If you have multiple tables you're choosing at once. This this one instance, we'll just do one table. And 3, select the columns to be queried. This chooser has many columns along the bottom, so you can arrange however you wish the columns you want. This is the chooser of which field, which column. It's saying it's a field, but it's which column will come first, using the pull down slip. So you can say, okay, well, I want soil to come first. So I highlight soil, and that will come at first at the end of the query. And then in this instance, we've selected soil type, farm product, and whether we want drought tolerant. So let's actually do this in the system. Close this table view, go to queries, create a query and design view, and this brings up first a window which allows us to choose which table we want to query. We're only doing one here, so we'll select farm product and hit add, and then we got to close. Manipulate the window a little. We want to open this little window here, which gives us a list of all the columns in the farm product table. This is turned on its side. Imagine the farm product table be rotated 90 degrees to the right, and those would be the column headings. So the original table, as you know, has crop number first, which is just serial number of the crop, then farm product, then growing season. So I want to rearrange the table. I want to arrange by soil type. Okay, then I want to arrange by, let's see, farm product. So we're going to have a list of all the soil types, and then we're going to have the farm products available. And then let's say we want profit per acre, that's always useful. So this is going to, we've selected 3 columns, and this is all the information we want. We don't want anything about whether they're drought tolerant, or how much they cost. We don't need the crop number. We want to limit our information so it's easier to read. We have less information so that the patterns stick out better. This is the function of a query. And right here is the query button, which will return the table. Return the table, which is the result of the query. Okay. Here we have 3 columns, and we have altered, of course, so that soil type is over to the left. Let's we do have to sort them so that all the soil types stick together. Okay, so we see the opportunities we have here. If we have bottom soil, we can grow barley and oats and make a lot of profit. If we have a loam, we can grow sorghum and make an enormous profit. If we have sandy soil, we can make okay profit. Clay, Timothy. Timothy is the grass from which you make hay. Not great profit there. But this is we could also sort by profit per acre so that we get an idea of what's the highest profit. If, most business people want highest profit first. And we could rearrange the entire query by profit. And then let's just put a soil type there. Run the query again. Of course, business people are always interested in profit. Sort it A to Z, or Z to A. There's our highest profit right up front. So this is the function of a query. It allows you to slice and dice information, rearrange it, and after you've rearranged it, sort by whatever criterion you think is best. Can't do this in a spreadsheet unless you use one of the pivot tables, which are very useful, but this is a standalone product, which I prefer. And you can cut down the information that you need very efficiently. So that is a very basic query. We don't have to say it. Well, we'll save it as profit query. I'm going to pause. And so in this instance, we successfully queried one table using, and the little run query button returns precisely what we need. Now let's query two tables. Now, of course, two tables, you can't query two tables separately. You have to merge them into one table, and then you query that. And how do you merge two tables? Well, there's a criterion that they have to share a column with a common attribute. So in this instance, we have farm products and field, two different tables with two very different types of information. We want the field information off on its own table because we don't need it really when we're looking at crops. We have another table with farm machines, for example. We don't need to query that when we're looking at field information or farm products. But field and farm products share soil type because every crop has a different soil type and every field has a different soil type. So if you match those two columns up, you marry the two fields together into one, and then you can query that one table in any way you want. So you're operating a much larger assortment of data very efficiently. You will merge the two tables and soil type become one table in the result. And it's a very powerful tool. It just requires you to select more than one table in the table selecting box, and then you have to specify that the two tables have a shared attribute. In this case, both columns in both tables have the name soil type. They don't have to have the same name for them to be the same information in each column, but you use this little chooser to draw a little line which tells the computer that those two columns are going to be the basis of the merge or join of the resulting table that you query. You drag this little line. I'll show you how it works. And then you select the columns that you want to appear in your final result. And then you run the query. Of course, what we have now is, since we have two tables, we need to specify not only the columns that are going to be returned, but the tables from which they come. So there's an extra level of specification in the chooser. Very simple to do. And of course, as you see in the mid-top pane, you see the two different tables and the line you've drawn between the shared column, which is the join condition. And this is the result, which will be a table that has information from both tables, farm product and soil type and field type merged. So let's do this. Let's create another query. Create query in design view. Okay, and we're going to select farm product. And using Shift down or Control and pause. Sorry for a moment, I forgot that control doesn't work on this. Um, you select one table at a time, highlight it and click Add, and then close the chooser. Other ones you allow you to hit Control to select two with one mouse. Sorry. Um, these are the columns again for the two tables that we are querying. So let's make them. Let's open them up so they're visible. And these are all the columns in uh, the two tables with farm product and field. And remember, as I said, soil type is the shared value. And we just drag down, little clumsy, but there you see you've made an association between the two columns of like kind. And now now we have all these columns to select from in our final query. Now the thing is, now we have to select the table for each column that we're going to use. So select farm product. And then field is the column you're going to use. So let's select farm product, farm product. Farm product is the name of the table and of the column in this instance. Let's select farm product, soil type. And then let's select field name. Each field has a name. First we select the field table. Then we select the name of the field that has the same soil type that we want to return. This will only return the fields that have the soil type that match the farm product. And you don't have to select the table all the time, since you have two different tables you're selecting from. You have a binary choosing option here. The column number is preceded by the table number, so you can just select whichever option you want from the field chooser. So let's get the field manager. Okay, let's make the field visible. So this table will give us each crop, what soil it grows in, what fields are available with that soil type, and the manager of those fields. So let's run this query. Okay, so now we know, okay, if we want to grow Timothy, we have the option of the Boyd and Paget field, and if we want to do that, we have to contact Gupta and Pagels. If we want to grow flax, we have to use the Reasoner field, which is sandy. It's the only sandy field available, and we're going to contact Rather. Now a further specificity you can have here is you can limit by using criterion. You can limit which specific value you want. Someone comes to you and says, I want to only grow, I'm only interested in information on Timothy. So down here in the chooser below, you choose function. Well, we actually don't use function in this instance. All we need to do is type the criterion that we're looking for, which is Timothy. And then need an equal sign and run the query, and it will only return the information on Timothy. And these are the people we have to contact if we are going to um, grow Timothy. And soil type doesn't even need to be visible. It's not really relevant to our question. We want to know who to contact when we grow Timothy, whose fields are managed, who manages the fields where Timothy grows. So we could actually eliminate the visibility of soil type. It is the join condition that we use, but eliminate it from visibility and it disappears. So that is a two-table query. And we have used the chooser to specify only a specific product we want. Chooser has, we could make it Timothy or millet. I think millet was in our table. There are lots of or options down here on the bottom. Actually, that isn't returning. I think it might be a single quote. Maybe millet isn't in our. Let's remove all criterions. Yes, we didn't have millet in our table originally. So let's say Timothy or wheat or wheat. Then only the Timothy and wheat rows are returned. So you can see how useful this is if you want to edit down the information you need only to the information you need and eliminate all the information you don't need. Very useful. So that was a two-table query. You can have multiple tables. This is the thing with relational databases. You can have 10 tables merged and make very, very complex queries. You may not drag information from 10 tables, but when you're not using those tables, they sit undisturbed in your database and you don't have to rewrite that information every time you open and close a table, leading to potential transcription error. You only touch the tables which contain the information related to what you want to know. So let's create a report real quick. Report is a thing which will just, a nice executive summary, which will make it very easy for a printout for the layman to read, submit to the regulator or submit to the bank or something. Reports are just a nice presentation of a table you've already queried up and organized as you wish. So you select the reports function, and then you select whichever tables you want to be in the function. There's a chooser. Select which table or query you want to abstract from. Select what fields you want in your report. So you can, just like in a query, you can limit the fields you want. You want to select what columns you want in your report. And then you, let's see, the slide confuses columns, but we'll see how it works precisely. And this is the final result. It's very simple. It's not complex like running a query. Once we've run a query, let's save this query. Query 4. Close it. We have to open database function again. Go to reports. We're just going to use a wizard to create a report. I'm going to pause. So the wizard has come up again. Took a minute to come up because I had so many windows open. You select the wizard for report creation. These are all the queries I've made. These are all the tables. You can choose whichever one you want. So did the query 2 tables. Now you're inside the query that you want, and you're going to select all the columns you want. Leave out field name and finish. And here is your report. Very simple. A nice executive summary that you can present anywhere. Only retains the information you want, and it's a lot easier for the layman or end user of the information to see it, the consumer. So thank you for visiting. This has been part 2. I'll put up a card if you want to go back and look at part 1. Next up, we will be importing data because you don't have to go around creating tables. You'll have to create a table in the database system so that you have the specifications in advance, but then you can import gigantic tables into the database and use them without having to enter the data again. So you can find tables from anywhere and import them to your database, query them against each other. Very powerful, very useful tool. You don't have to enter the stuff in all the time, but you do have to tell the database what's coming. You do have to specify it in advance. Today we just did sorting and filtering, which are just like with spreadsheet utilities. And we did queries on 1 and 2 tables, and we created reports. This is the basic stuff in any relational database, which makes it different from a spreadsheet. Queries are different from spreadsheets.